Hello everyone, I am Faranjum from Sri Venkateshwara College of Engineering, Bangalore. The topic for the presentation is Network Software Protocol Hierarchies from the course Computer Networks. First, we will see what is a network. A network is a group of computers linked to each other that enables the computer to communicate with another computer and share their resources, data, and applications. A computer network can be categorized by their size. A computer network is mainly of four types. PAN, Personal Area Network. Personal Area Network is a network arranged within an individual person, typically within a range of 10 meters. LAN, Local Area Network. Local Area Network is a group of computers connected to each other in a small area such as building or office. WAN, Wide Area Network. A wide area network is a network that extends over a large geographical area such as states or countries. MAN, a Metropolitan Area Network. A metropolitan area network is a network that covers a larger geographic area by interconnecting a different LAN to form a larger network. Hardware and software are used to connect computers and tools in any network. Now we will see the functions of network. Firstly, it is used for communication. The primary function of computer networks is to enable communication between the devices. Then, resource sharing. Computer networks enable the sharing of resources among connected devices. Data transfer. Networks allow for seamless transfer of data between the devices. Information access. Through computer networks, users gain access to vast amount of information available on the internet. Collaboration. Networks foster collaboration by enabling multiple users to work together on projects and share information in real time. Centralized management. Computer networks allows for the centralized management of resources and services. Now we will see what is network software. Network software encompasses a broad range of software used for design, implementation and operation and monitoring of computer networks. Functions of network software. It helps to set up and install computer networks. It enables users to have access to network resources in a seamless manner. It allows administrations to add or remove users from the network. It helps to define locations of data storage and allows users to access the data. It helps administrators and security systems to protect the network from data breaches, unauthorized access, and attacks on a network. It enables network virtualizations. Now we will see what is protocol and protocol hierarchies. Protocol. A network protocol is an accepted set of rules that govern data communication between different devices in the network. It determines what is being communicated, how it is being communicated, and when it is being communicated. Network protocols are the backbone of modern-day communication. Protocol hierarchies. A protocol hierarchy in computer network refers to the organization and arrangement of network protocols in a layered structure. This layered approach helps in achieving interoperability, modularity, ease of implementation, and maintenance within complex network systems. Network hierarchies offer several advantages for efficient network design and management. Network software protocol hierarchies. The first computer network were designed with the hardware as the main concern and the software as an afterthought. Network software is now highly structured. To reduce their design complexity, most networks are organized as a series of layers or levels, each one built upon one below it. The number of layers, the number of each layer, the content of each layer, and the function of each layer differ from network to network. The purpose of each layer is to offer certain services to the higher layers, shielding those layers from the details of how the offered services are actually implemented. Violating the protocol will make communication more difficult if not impossible. In reality, no data are directly transferred from layer N on one machine to layer N on another machine. Instead, each layer passes data and control information to the layer immediately below it until the lowest layer is reached. Below layer 1 is the physical medium through which actual communication occurs, as seen in the figure. Between each pair of adjacent layers, there is an interface. The interface defines which primitive operation and the services the lower layer offers to the upper one. One of the most important considerations is defining clean interfaces between the layers. A set of layers and protocol is called network architecture. The specification of architecture contains enough information to build the software or hardware for each layer so that it correctly obeys the appropriate protocol. A list of protocols is used by a certain system. One protocol per layer is called a protocol stack. In addition to minimizing the amount of information that must be passed between layers, clean-cut interfaces also make it simpler to replace the implementation of one layer with a completely different implementation, because all that is required of the new implementation is that it offers exactly the same set of services to its upstairs neighbors as the old implementation did. For example, a message M produced by the application process puts a header in front of the message to identify the message and passes the result to the next layer. The header includes control information such as a sequence of numbers to allow the next layer in the destination machine to deliver messages in the right order, as seen in the figure. Headers may also contain sizes and sometimes other control fields. The layers break up the incoming messages into smaller units, packets. For example, message M is split into two parts, M1 and M2. A layer decides which of the outgoing lines to use and passes the packets to the next layer. This layer adds not only a header to each piece but also trailer and give the resulting unit to the layer below it for physical transmission. At the receiving machine, the message moves upward from layer to layer with headers being stripped off as it progresses. None of the headers for layers below N are passed up to layer N. The pure process abstraction is crucial to all network designs. The task of designing the complete network can be broken into several smaller manageable design problems, namely the design of the individual layers. Thank you for watching the video.